So we will take another example, that is a 2 cross 3 linear convolution given by SP is equal to HP dot XP, where HP is H0 plus H1P and XP is equal to X0 plus X1P plus X2P square, and we will use Cook's Toom algorithm to construct an efficient implementation for the given linear convolution. So starting with direct linear form, so just to make a comparison, first I will implement it using direct form, then I will use Cook's Toom algorithm to implement it. So using direct form, SP is HP dot XP, substituting the value of H of P and X of P. So this is H0 plus H1P and X0 plus X1P plus X2P square. So that is H0 X0 plus H0 X1P plus H1 X0P plus H1 X1P square plus H1 X2P cube plus H0 X2P square. So S of P can be written as S0 plus S1P plus S2P cube, as the degree of SP will be 3. 2 into 1, that is 3. Highest degree will be 3. And rearranging this equation, we have H0 X0 plus P common, H0 X1 plus H1 X0 plus P square H1 X1 plus H0 X2 plus H1 X2P cube. So total multiplication is 1, 2, 3, 4, 5 and 6, and total additions is 1 and 2. So using direct form, this can be implemented using 6 multiplication operation and 2 addition operation. Now we will implement it using Cook Toom algorithm. Okay, so the first step is to choose L plus n minus 1, that is L is 2 and n is 3. So 3 plus 2 minus 1, that is 4. You have to choose 4 different real numbers. Beta 0, beta 1, beta 2 and beta 3, that is starting from beta 0 to beta n plus n minus 2. Okay, so let beta 0 is 0, beta 1 is 1, beta 2 is minus 1 and beta 3 is 2. So you can start by assigning small integer values. Step 2 is compute h of beta I and x of beta I for I equal to 0, 1, 2 and 3. So for I equal to 0, 1, 2 and 3, we have to compute this value. Okay, so beta I, beta 0, beta 1, beta 2 and beta 3. So beta 0 will be 0, beta 1 will be 1, beta 2 is -1 and beta 3 is 2. We have to calculate h of beta I, that is h0 plus h1 beta I, and you have to calculate h of beta I, that is x0 plus x1 beta I plus x2 beta I square. Okay, so h of beta I for this values of beta will be h0 plus h1, h0 minus h1 and h0 plus 2 h1, and at this point it is x0 plus x1 plus x2, x0 minus x1 plus x2 and x0 plus 2x1 plus 4x2. Okay, so this is h of beta 0, this is h of beta 1, this is h of beta 2, and this is h of beta 3, and this is x of beta 0, this is x of beta 1, this is x of beta 2, and this is x of beta 3. So in the third step you have to write s of beta I is equal to h of beta I into x of beta I for I equal to 0, 1, 2 and 3. Okay, so s of beta 0 is equal to h of beta 0 x of beta 0, s of beta 1 is equal to h of beta 1 into x of beta 1, s of beta 2 is equal to h of beta 2 into x of beta 2, and s of beta 3 is equal to h of beta 3 into x of beta 3. So at this point you can see that 4 multiplications are there. Okay, so you have to just write, you don't have to substitute the value of h of beta I, x of beta I and multiply at this point. So the next step is to compute xp using Lagrange's interpolation formula. So s of p will be equal to s of beta 0 into p minus beta 1, p minus beta 2, p minus beta 3 divided by beta 0 minus beta 1 beta 0 minus beta 2 and beta 0 minus beta 3 plus s of beta 1 into p minus beta 0, p minus beta 2, p minus beta 3 divided by beta 1 minus beta 0, beta 1 minus beta 2 and beta 1 minus beta 3 plus s of beta 2, p minus beta 0, p minus beta 1, p minus beta 3 divided by beta 2 minus beta naught, beta 2 minus beta 1, beta 2 minus beta 3 plus s of beta 3 into p minus beta naught, p minus beta 1, p minus beta 3, beta 2 divided by beta 3 minus beta naught, beta 3 minus beta 1, beta 3 minus beta 2. So now putting the values of beta 0, beta 1, beta 2 and beta 3 and rearranging the equation, we have s of p equal to s of beta 0 plus p and in the bracket s of beta 0 by 2 plus s of beta 1 minus s of beta 2 by 3 minus s of beta 3 by 6 plus p square minus s of beta 0 plus s of beta 1 by 2 plus s of beta 2 divided by 2 plus p cube s of beta 0 by 2 minus s of beta 1 by 2 minus s of beta 2 by 6 plus s of beta 3 by 6. Okay, so s of p can be written as s0 plus s1p plus s2 p square plus s3 p cube, and comparing this to equation, I can express both the equation into a single matrix form. So in the left hand side I have a column matrix with 4 rows, S0, S1, S2 and S3, and on the right hand side I have a 4 cross 1 matrix, that is S of beta 0. In second row I have S of beta 0 by 2 plus S of beta 1 minus S of beta 2 by 3 minus S of beta 3 by 6. The third row we have minus s of beta 0 plus s of beta 1 by 2 plus s of beta 2 by 2, and in the last row we have s of beta 0 by 2 minus s of beta 1 by 2 minus s of beta 2 by 2 plus s of beta 3 by 6. Okay, 6 at this point also. Okay, so now I will separate this matrix in steps. Okay, so looking at the last term, it is having all the values s of beta 0, s of beta 1, s of beta 2, s of beta 3. So I can separate s of beta I into a column matrix. So I have s of beta 0 by 2 and s of beta 1 by 2, and for this s of beta 2 by 6 and s of beta 3 by 6. So this is a 4 cross 1 matrix, and the post computation matrix will be of 4 rows. It is mandatory, and number of columns will be also 4. It depends on this 4 cross 4. So now I will select the terms based on this matrix. So s of beta 0, the first term should be 2. 2 into s of beta 0 by 2 gives s of beta 0, and remaining values will be 0. So in the second row we have minus s of beta 0 by 2, so minus 1, s of beta 1, so plus 2, minus s of beta 2 by 3, so minus 2, so minus 2 into s of beta 2 by 6 gives minus s of beta 2 by 3, and here s of beta 3 by 6, so minus 1. Okay, so in the similar way, in the third row we have minus 2, 1, 3 and 0, and in the last row 1, minus 1, minus 1 and 1. Okay, so now s of beta I can be written as h of beta I into x of beta I. So I can again decompose this matrix as x of beta 0, x of beta 1, x of beta 2 and x of beta 3, separating this terms that belong to x into a column matrix, 4 cross 1, and this will be a 4 cross 4 matrix. So the first value will be h of beta 0 divided by 2, h of beta 0 divided by 2 into x of beta 0, that gives the first term. So the remaining columns are 0. The second row, x of beta 1 is there, so this term will be 0, this term will be h of beta 1 by 2. and the zero remaining terms are 0. In third row, x of beta 2 is multiplied with h of beta 2 by 6. So the third column in the third row will be h of beta 2 divided by 6, and similarly the last row, this value will be h of beta 3 by 6, h of beta 3 by 6, and the remaining values are 0, and this is as it is.